once you have LLMs in production or you're starting to talk about LLMs in production, a lot of organizational kind of challenges and conversations that come up about governing and ensuring that I don't know that LLMs are operate really well within the production in real world. And so quick kind of intro on Arize and using a program with. Arize AI was basically observability for any AI or ML models in production. So think about LLM models, think about I heard about the generator transformers that you have some text, image, or even more kind of, if you will, traditional MLs, where we're looking at member search ranking models, forecasting models. All those benefit through an observability layer. Make sure that one, the model is actually performing, and then when something goes wrong, you actually get a quick notified of that. And so kind of thinking about who actually uses observability for the models. And these customers, or paying customers, they're not just using a library using the input, they're typically partnering with us to enable observability across all the models within the organization. A lot of them are actually partnered with us and Google. So if you think about getting up to scale with Google Vertex, using Google BitPro, using GCS, investing in the ecosystem right now, they still partner with us with the likes of Etsy, Wayfair, some of those. Level setting on overall observability. It's not something we came up with. It's been really pioneered across kind of BPM and DevOps, where we really have this concept of one proactive alerts and monitoring. So I don't want to go into a platform, run code in a notebook every day, every hour, to see if something's going wrong or not. I want to get meaningful signals to know, hey, something's arisen, hey, go check into the platform and figure out what's going on. Then you're going to want to have overall kind of a pre-native workflows to figure out what's going on. You don't want to get back into code, start fumbling with ETLs and exports from the data lake, and starting to transform that, visualize that data, and then go through that in cycle. That data is already in a platform to enable you to overall dive really quickly into what's driving that alert, that signal to actually go off. And then you also want to make sure that you're going through this iterative cycle of enabling a feedback loop and know the data. You know what's actually causing the issue with the root models, and you're actually enabling us to actually take action on those insights very quickly, and making sure that you can, when you release that improvement, you actually monitor alerts, etc. So overall, we see models as kind of these little kind of feedback loops that really need proactive monitoring and overall continuous observability. So let's get a little bit more into kind of what does it tactically look like and what are the kind of trends that we see within the tool. Very similar to the software development toolchain, very similar to general ML kind of toolchain. We're seeing an emerging LLM toolchain. Of course, this might change and kind of fluctuate as we get a rips and read rips as well. But this is what we're kind of seeing here. One is you kind of pick and go with the third-party LLM provider. Most specified here with OpenAI, but there's a lot of others that are out there. Things like Google, like Palm, Dolly, etc. What we're going to also want with and really supercharge that kind of LLM is enable utilization of the vector database. And so you see target ones of Vertex AI, Biogen, and then you want some sort of orchestration layer on top of all that. So this is very crucial. Therefore, you know that using things like branching or long index and also want observability. Keynote on the rise, but not accepting of that. So you can pick and choose what's best agreed, what really works for your organization. And thinking about these kind of building blocks, what does that actually look like at an organization? And we can move into deploying and actually developing LLMs. They start building and using these building blocks and enable kind of 3 or 4 kind of use cases that we see in the world. So the first one is like systems. Think about you're using proprietary data. If you're, for instance, a financial services platform and you're trying to figure out what sort of stocks, what sort of options should I suggest and actually recommend to these clients, or which sort of kind of groups of these clients should I actually start engaging with. You're going to really keep a lot of things in-house and have these in-house assistants built. So it's not exposed to the real world, if you will. Through a particular website, you're actually just exposing the kind of insights through an human agent that utilizes that tool. The one that we're probably a lot more familiar with is an application of chatbots. You go to a website, hey, you're out of the internet, or why isn't your phone not working? Why is this chatbots? Overall, this is kind of the use case I'm going to start focusing on. We go through this presentation, but just know that there's other kind of use cases of LLMs out there. The last one as well is generative. Hey, like type something into Adobe, make this picture, and get rid of this red eye and the people in the background. That's kind of a more generative use case of well. Think about those building blocks that we talked about before. This is what it actually looks like for the workflow that for our customers that we know. So if you're thinking about that chatbot, what happens first? I go to a website, I interact with that chatbot. So hey, this board, for instance, that's your user query. And then one of two things are going to happen. You could go directly and take that query and have it interact with your LLM. More than likely, what you're going to do is create an embedding of that representation of that text and actually start querying your vector store. And using something like a cosine similarity to see, hey, what's actually similar, what sort of contextual kind of knowledge base or overall article should I pull, retrieve, and actually bundle. So within that once right here, we're kind of bundling that kind of user query with the context that we retrieve with the prompts. A little side note here that we also know from customers, when you think about ML models that maybe you're familiar with, kind of iterating through various kind of retrainings and loading that through the filtering. We're actually seeing that the prompt itself that you actually provide to the LLM is becoming akin to that kind of model version. So a little a shift in where we can apply the lineage in the models. Relevant information, whether it's just the original query or that kind of bundle from context in the query to the LLM that ultimately actually exposes or creates the actual response that ultimately is exposes the user. And then, of course, ideally you get user feedback, but I think we all know how well we do on exit surveys when we go through surveys with any kind of vendors. So that can be hit or miss. So you need other signals within this kind of realm or workflow to actually understand, hey, or is there kind of a drop off in deployment and things like that. Where anything which you really arouse is the knowledge so the handoff processes. And so really it could be at the start, it could be bad retrieval. Maybe I'm just not finding the right information within the vector database. Perhaps I don't have coverage within the vector database. There's a gap that I actually need to fill in because we have not actually marking my LLM with the right information. Perhaps it's just taking too long. How do we know that the literal performance of an agent performing all this is actually doing this efficiently and efficiently? Other particular questions, queries that are actually driving my LLM or agent performance to actually have very, very long latent periods between all this process. Maybe my LLM is just doing things, giving wrong information, making up things. That's not great if you're exposing that to your customer. And then, of course, I get feedback. Some people give me thumbs up, thumbs down, rejected, accepted, etc. How do I actually use those data points to actually start improving my data? That's where we come in. You need observability across all of these. So think about taking observability to take all these data points, including the original embedding of that actual text prompt to the retrieval and what did I actually retrieve. Another thing that's novel and pretty bold, we're using LLM to actually generate and make sense of all this, these queries and in this context. You can also use LLMs to actually evaluate how well your LLM is doing. We have that whole another talk on that. But we're seeing a lot of our customers using, for instance, as an AI to actually say before, hey, is this kind of a retrieved context actually relevant or not, and help sort of relevancy score there. And then, of course, consuming those kind of feedback. So through the thumbs up and thumbs down within your workflow there. what I'm saying here is you want this to do this at scale. You don't want to have to use one SDK or one integration point. Different teams might operate differently. So just know that Arize works across a lot of different languages. Most DLs code or we work with Python. So Python SDK, Java SDK, etc. We also work with table views. So a lot of larger customers grab from an existing Google BigQuery and do some ongoing input of those data into the platform. And then if you already have that one, you can already just grab a bunch of algorithms and grab them there. Yeah. And it's like the whole forward to ask the questions because it's not really that good. But what we'll do here is we're going to look into the question. But we don't actually look at what sort of workflow that we just kind of touched on. How that actually manifests in a solution. So what you see on the screen here is, our platform data. We're kind of observing the chatbot and the other screen here. Orientation on the screen here is think about the top one from here is drift up. It says production. So like what are we doing in the real world? Down below here, we kind of an example of, hey, here's actual predictions over a time horizon, right? So we're going to have 30 days of predictions, and we're looking at this creative area here. And so what we're doing is we're comparing that against my model baseline. And behind the scenes, or really what those data sets actually represent is one, this is a combination of that context and the prompts and the original query that my user asked for. So it's the combination of all that compared against the representation of my vector database. So what sort of knowledge is actually there? So what we're doing within this is we're measuring, do we have good coverage? Another way to think about this is a query density, but overall, we're going to use the Euclidean distance to understand is there good coverage and how do we know that? When my Euclidean distance is low, that means things are very aligned. When my Euclidean distance increases, that means something within this overall embedding space is becoming different. And so that's what's going to drive and look. For instance, if you know what I mean, she said, hey, come into a platform like Arize and actually figure out what's going on. And so you'll see that we have a little spike here, and we're kind of looking at a return to, if you will, normal, but that's all relative. If you come down here, a very common question is that as we kind of look at the top portion and we start looking at the second portion here is, hey, I think these clusters that are being identified, is this the average Euclidean distance between clusters? The answer is no, we're actually looking for average Euclidean distance between the average central of the two data sets available. And then what I want to do is, if you think about data vector, it's or vector representation, it's a lot of the array numbers. That's not going to be very useful for you to really factor. So what you want to do is take those dimensions and reduce them down. What we're using is Gmail. If you're familiar with like something like TSMU, it's not like a much more 15-minute factor kind of way for us to socialize these vectors into the 3D space here. Second part here, what we're doing is we're looking at identifying clusters within the embedding space. So you see as I move this cluster or this the cursor, you see that the little purple portion here is kind of like showing you what actual points are being selected or will be selected. I can select the points, and then what I can do is I can quickly look at all these kind of various prompts and responses and get a general sense of like, okay, like this looks like all kind of Spanish responses. I can get into more detail like it looks for the prompt category, rows or length, rows or response length. And I can review the ones that are kind of having this imbalance between production and my basic. These are the ones I don't have coverage between my vector database and what we're actually getting queries in the real world. The last thing I'll kind of tie off here, or one or two things I'll tie off here is the last application that we actually thought of using LLMs is actually saying, hey, like maybe I don't actually know what exactly is going on here. It looks like some sort of what is going on with the prompts and the responses. But I can actually do is I can tap into another LLM. You can use ChatGPT. I can say, hey, can you summarize this question for me and tell me what's going on here? And so there's a lot of applications within LLMs. So we're understanding what's going on. The last person about observability is making sure that we actually know what to do next. Find what's actually driving, what's having imbalances between production and the reduction database. The last thing we're going to want to do is try to export that data. So offline, we have a whole suite of open source tools that goes by the name of Phoenix. So you can actually export this data from our product, you go back into Phoenix, and now in a notebook with a lot of these visuals and user flows. And so we're really working together with kind of offline and more granular technical and analysis and getting the store that actually quickly put into interest. The last thing I'll leave you here with is a lot of what I want to do, as I mentioned, like flows are built into Phoenix. So feel free to go open source and